Hello class, this is Mrs. Smith and this is your lesson on the scientific notation. At the end of this lesson you should be able to convert numbers into and out of scientific notation. Please write these down in your notes. Scientific notation is a way to eliminate the placeholder zeros in a measurement. If your measurement has lots of zeros, we want to try and eliminate those to make it quicker to write. You can see these numbers are pretty large or contain many zeros. As you can see, this measurement right here has lots of zeros and we want to try and write the number in the simplest way possible, taking up the least amount of space. The human eye blinks 4,200,000 times a year. In order to convert this number to scientific notation, you have to be aware that only one digit stays in front of the decimal point. Therefore, we want to put our decimal point on this number and move over as many times as it takes to get the decimal point so that there's only one digit remaining in front of the decimal point. So we're going to move it 2, 3, 4, 5, 6 times to get this number to be 4.2. And then by moving the decimal point over one decimal place, that's really a factor of 10. So converting this number, 4,200,000, it turns the number into 4.2 times 10 to the 6th times. So this exponent here tells you how many times to move the decimal point. Here, the mass of a proton is a very, very small number. And we're going to denote that the original number, was smaller than the number that we're going to have in the outcome by making the exponent a negative exponent this time. You can see the original number up here was larger than 4.2, so we have a positive exponent. So now we're going to move our decimal point over so that one digit is in front of the decimal point. So this 1 is going to be in front of the decimal point, and now we're going to count how many times we have to move it over. 3, 6, 9, 12, 15, 18, 21, 22, 23, 24. We move the decimal point over 24 times, 1.673 times 10 to the negative 24th power, and we keep our unit on our measurement as well. 2 more examples, now moving numbers out of scientific notation and into regular notation. Just by looking at this number, I can tell that it's a large number by looking at the exponent, and the exponent itself is positive. That means I'm going to need to make this number larger by moving the decimal point over 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So what I'm going to do with these empty spaces is just fill in zeros in those spaces. 5, 1, 1. And now I have 6 remaining slots for zeros. 1, 2, 3, 4, 5, 6. That means that this number was in fact 511 million degrees Celsius. The weight of one atomic mass unit, or AMU, you will be using this measurement later on in chemistry, AMUs, so it's good to have a little background on it now, is 1.66 times 10 to the negative 27th kilograms. The negative 27 denotes that this number is a very, very small number, and I'm going to move this decimal point back 27 times. Now this is really easy when you have a negative exponent. All you have to do is look at this negative 27, and you're going to move it back 27 times, so that means if I move it back 1 time, I'm going to have 26 more zeros in front. So you put your decimal point and then 26 zeros. 20, 21, 22, 23, 24, 25, 26, 166 kilograms. Crazy long numbers. So you can see the utility of using scientific notation in these extremely large numbers. Hopefully now you'll be confident in converting some numbers when you come to class to practice. See you in class.